Okay, guys, so take two. We're going to try this again because I know the other one has a robotic voice. We'll see if it works this time. So, this video is 10.1. We're going to be working on multiplying with the same base. And I'm sorry if you hear the keyboard so loud because, I mean, it's a loud keyboard. But it's multiplying powers with the same base. And I'm watching the video, the last one I put in the background, and we're going to see if this works, okay? So, what do we mean by a base, okay? If you have 2 to the third power, okay, the number that is being raised to an exponent, that's called the base. Okay? So, problems will look a lot like this. 2 to the third times 2 to the second. Okay, pretty easy to calculate, but we're trying to go a little bit deeper than that. So 2 to the second, 2 to the third, and 2 to the fifth. I want you guys to solve those real fast, and also solve 3 to the second times 3 to the fourth equals, not equals, but I also want you to solve 3 to the sixth. Okay. And after you solve those all out, I want you to answer that question. Do you notice a pattern in the answers? A pattern between the answers? Pattern between the answers, and if there's a pattern like in the exponents. Do you see some kind of pattern? So, your time to try it. Dun, 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 dun. Alright. Well, the 2's, 2 to the second, that's 4. 2 to the third, that's 8. And 2 to the fifth is 32. Okay, I'm not sure if you guys could hear that, but that was my tablet that I just discovered works for the first time in 2 years, and it plays Lion King when I wake up. No idea why. Okay, so 3 to the second power is 9. 3 to the fourth is 81. And 721. Sorry, 729 is 3 to the sixth. Okay, so do you notice a pattern? Okay. Well, here's something you should see. Where my mouse go? Okay. If you take a look, 4 times 8, that's 32. And 9 times 81, 729. What you also should have seen, though, is the exponents. You have 2 to the second, 2 to the third, 2 to the fifth. 2 plus 3 is 5. 2 plus 4 is equal to 6. So this is what we call the power rule. Okay, this is called the power rule. The power rule says a to the m power, any number, any base, times a to the n power is equal to a to the m plus n power. Okay. So an example of this would be like if you're trying to multiply a couple exponents together. So a to the second times a to the third. If we were trying to multiply that out, okay, this is a times a, and 3 a's is a times a times a, a times a times a. All of those a's combined give you 5 a's, or a to the fifth. So that's how the power rule works. Okay. Feel free to stop it if you need to. Otherwise, I'm going to go on to the next page. Alright, next thing. Anything to a negative power flips across a fraction bar. Yeah. So here we go. If you have 2 to the negative third power. 2 to the negative third power, we can write this as a fraction, 2 to the negative 3 over 1, but we have that negative exponent we have to deal with. So to deal with that negative exponent, you take this number and you move it down underneath the exponent. It has to go down here. So now this becomes 1 over 2 to the third. Which equals 1 over 8. Another example. 2 to the second over 3 to the negative 2. 2 to the second stays on top because it does not have a negative exponent. It doesn't need to move. However, since 3 to the negative 2 is a negative exponent, it needs to flip across the fraction bar. So now 3 to the second power goes on top, and this is all over 1. So 2 to the second is 4, 3 to the second is 9, for a grand total of 36. Okay. So just be aware you got to flip the negatives across the fraction bar. You're good to go. Okay, we'll do a little smiley face right here just to say that we should be good. Alright, another example. Okay. So what's 2 times 3? 6. What's 3 times 2? 6. So it doesn't matter what order you multiply things in, you get the same answer. So when we have an example like 2 to the second times x to the second times 2 to the third that's a really ugly 3. There we go. Times x to the negative fourth. Okay. What we can do, because when we multiply, it's a commutative property, meaning you can switch things around. Doesn't matter which order you multiply things in, you still get the same answer. Okay. It does matter which order you divide in, but which order you multiply in doesn't matter. So we're going to use that property to switch these guys. And this becomes 2 to the second power times x, whoops, times 2 to the third power times x to the negative 2, nope, x to the fourth times x squared. Actually, I accidentally moved them all over again. Sorry about that. X to the second times x to the negative 4. So 2 to the second times 2 to the third, that's going to give us 2 to the fifth. Okay, because we have the same base, we can add the exponents together. And then x to the second times x to the negative fourth, we combine those exponents together. 2 minus 4 gives us x to the negative 2. So the positive exponent stays on top of a fraction. Negative exponent has to drop below the fraction bar. Okay, I've got a good song for this too. If the exponent's negative, drop it like it's hot, drop it like it's hot, drop it like it's hot. I'm sorry, I won't sing anymore. But if it's a negative exponent, you drop it below the exponent, or below the fraction bar. So 2 to the 5th is equal to 32, and x squared is on the bottom. Okay. So another problem that you are likely to see is they'll give you a problem like this. They'll say, okay, 2 to the blank times 2 to the 3rd equals 2 to the negative 1. So what they're asking you for is question mark, what's supposed to go in there? What needs to go in there such that when we combine the exponents together we get negative 1? So we can call this an x. 2 to the x times 2 to the 3rd power equals 2 to the negative 1. Since the bases are the same, they all have a base of 2. Okay. We can combine these together. So this is x plus 3 equals negative 1. And x plus 3, we get rid of a plus 3 by subtracting 3 to both sides. And we get x equals negative 4. So negative 4 is the number that we would plug right in here to make this equation work out. Okay. One more example. If you have 3 to the 2nd power times 3 to the 0 power, not 0, that should be to the blank power, we don't know what this is yet, equals 1. Now you should be thinking to yourself right now, you're looking at this and you're thinking, Mr. B, please stop messing up. But I promise, I didn't mess up this time, okay? This 1 is really important. See, this has a base of 3. And this other guy has a base of 3 too. Sorry, I'm late to Pride Rock. Alright, so 3 to the 2nd times 3 to the blank power is 1. Since these have a base of 3, we can rewrite this number 1 and a base of 3, because any number at all, if you take any number and raise it to the 0 power, you get 1. So 3 to the 2nd times 3 to the x power equals 3 to the 0 power. Okay. So now that we have all even bases, we got to get the exponents the same. This is 2 plus x equals 0. Subtract 2 from both sides, and we get x equals negative 2. Okay. And that's it. That is the conclusion of our lesson. Hopefully this comes out a little bit better audio-wise. And last thing, don't forget the form in the description. Okay, thanks for watching, guys. See ya.